So definitely, hi guys. Welcome to this video. And in this video, we are going to look at one of the fundamental courses in ICT, which is database technology. So database technology is one of the essential courses in information and communication technology. So please pay attentively as you listen to this important lesson. So to start with, you need to understand what database technology is all about. So the first thing that we're going to look at is we shall look at database design techniques. So we're going to look at database design techniques. So when you look at database design technique, design. So database design is a crucial aspect of creating efficient, scalable, and maintainable database. Database design technique, it is very crucial for creating maintainable database. So proper design techniques are essential for ensuring data integrity, security, and performance. So if the database design techniques are in a proper way, or if the database design technique helps to ensure data integrity and the performance. So it is very much important that you need to follow the aspect of database design technique. And then apart from that, we have what we call database design techniques. So we have 20 database design techniques. We have 20 database design techniques, which are very fundamental, So there are 20 of them. So the first database design techniques is the requirement gathering. Now, when you look at the aspect of the requirement gathering here, it emphasizes that you should be able to interact with the stakeholders that are in need of the database. You should be able to interact with the stakeholders, which is very much important when you look at point number 2, interview stakeholders to determine their needs and what they expect. So you should be able to interview and interact with the stakeholders so that you are able to see what they need and what they want in that database. And then the first point is that start by understanding the system requirements, including data type, volume, and access pattern. It is very much important that you also understand the aspect of the data type that you are using. Very important. You should be able to understand the data type that are using. Yes, guys. So, and just like that, yeah. I think the weather is changing, I guess. It's because of the lens season. Yeah, the weather is changing. Yes, guys. So apart from requirement gathering, we also have another database design technique. We also have another database. Okay, so the database design technique, which is entity relationship diagram. So entity relationship diagram. So when you look at entity relationship diagram, use entity relationship diagram to model the data structure. So you use the entity relationship diagram to model the data structure, showing entities, attributes, and relationship between them. So entities represent the real world. So entities represent real world objects. Attributes are properties of entities, and relationship defines how entities are connected. So it is also very much important that you consider the aspect of entity relationship diagram in the database perspective, in the database design technique. Very important. And then these entities, they must be connected to create a relationship. So remember, we have talked about the requirement gathering, and then we have also talked about the entity relationship diagram. All these falls under database design techniques. Apart from that, we also have another technique, which is normalization. So on the aspect of normalization, normalize the database to eliminate data redundancy. So normalize the database to eliminate data redundancy and improve data integrity. So you should be able to normalize the database to eliminate data redundancy. Keeping of same data for a long period of time, maybe the data is not even in use, it is not even important. So one of the database design technique is to normalize. So you normalize the database to eliminate data redundancy and improve data integrity. And then there is also an aspect of follow normal forms. You should be able to follow normal forms, and these normal forms are 1NF, we have 2NF, we have 3NF, and we have BCNF to minimize data duplication and maintain consistency. So in order to maintain the consistency of the data in your database, you should follow normal forms such as 1NF, 2NF, 3NF, and BCNF, just to minimize data duplication and maintain consistency. Apart from that, there is also an aspect of denormalization. There is also an aspect of denormalization which also plays an important role in database design technique. So when you look at denormalization, sometimes it is necessary to denormalize certain tables for performance optimization. So it is also very much important that you remove certain tables within your database just for performance optimization of your database. And then you should carefully consider which table to normalize and monitor the impact of query performance. It is also very much important that you should take into consideration the kind of tables that you're removing, so that you don't intend to affect your database. It is very much important. And then the other database design technique is data type. So data type is also one of the fundamental database technique design. So when you talk of data type, choose appropriate data type for each column to optimize storage and retrieval. So now when you talk of this aspect, you should be able to choose the appropriate data type for each column to optimize storage and retrieval. And then there's also a point of using integers for your primary key. So there's also an aspect of using integers. Integers, these can be numbers. So you use integers for your primary key, dates for date field, and appropriate text or binary for other data. Apart from that, there is also an aspect of indexing. So indexing is also another database technique design or another database design technique. So when you talk of indexing, create indexes on column frequently used in search and join operations to speed up query performance. So in order to speed up query performance, you should be able to create indexes on column frequently in frequently used in search and join operation to speed up query performance. And then there is also an aspect of be cautious not to over-index. Again, over-indexing can affect your database query performance. So you should be able to be careful enough not to over-index, as it can impact insert and update operations. Okay. Apart from that, there is also an aspect of primary keys. which is number 7 on database design technique. So when you talk of the primary keys, designate a primary key for each table to ensure uniqueness and the data integrity. So in order to ensure data integrity, the aspect of primary key is also very much important. It is also very much important when you want to designate the primary key. So the aspect of primary key is very much important. And then there's also on the primary key, second point, we're talking about auto-incrementing integers or unique identifier are commonly used for primary key. So unique identifier are also primary used for the primary key. Apart from the primary key, we have a foreign key. So now when you talk of the foreign keys, define relationship between tables using foreign keys. Define relationship between tables using foreign key. So if you want to identify the relationship between tables, if you want to identify the relationship between tables, you use the foreign keys. And then there's also an aspect of enforce referral. There is also an aspect of enforcing referential integrity to maintain data consistency. And then that is just part of the foreign key. And then we also have the aspect of we also have the aspect of constraints. I guess the weather is just different here. I know I don't know where you are if maybe you are not experiencing lenses on the order, but here definitely it's learning everything. Yes, okay, guys. So we're still looking at the database design techniques. We are on number 9, which is constraints. So when you talk of constraints, guys, use constraints. So here you are advised to use constraints. So constraint, e.g., check, unique, not, or new. So these are constraints that you can actually use in your database. You can actually use check, unique, not, or new to ensure data integrity and enforce rules. So in order to ensure data integrity, you can use constraints such as check, unique, new, or not. These are part of the constraints which are very much important in database design technique. And then there is also an aspect of implementing business logic in the database through constraints. So there is also an aspect of implementing business logic in the database through constraints. Very important. Apart from that, there is also an aspect of petitioning, which is also number 10 database design technique. So petitioning, it emphasizes on petition large tables to improve manageability. So if you want to improve manageability, petition large tables to improve manageability and query performance. So you need to petition large tables. So you petition the large tables to improve manageability and query performance. So in order to improve your manageability and query performance, you need to petition. You need to petition your tables. So horizontal petitioning divides a table into smaller sub-tables. So when you talk of horizontal petitioning, it divides a table into smaller sub-tables. So it divides horizontal petitioning, divides tables into smaller sub-tables. And then we also have an aspect of vertical petitioning stores. When you talk of vertical petitioning, it stores specific column in separate tables. Okay, so apart from petitioning, we also have the aspect of data security, which is also number 11 on database design techniques. So when you talk of data security, we are emphasizing that you implement access control. And so here we are emphasizing on implementing access control and authentication mechanism to protect sensitive data, utilize a role-based access control to manage user permission. Okay, guys, so Yeah, it has even started learning. Okay, guys. So now we're still looking at the aspect of data security. So here there's an aspect of authentication. That is, if you want to, you are protecting your database. So there's an aspect of authentication, and authentication emphasizes that you need to use passwords, and these passwords should be strong enough. Maybe you are using AES 256 kind of password, which is strong password. And imagine when you talk of passwords, in order to protect your database, you use strong password. And this strong password must include the uppercase and also must include the lowercase. It must include special characters and numbers. Okay, so that is the aspect of security. And then there is also an aspect of data achieving. Now, when you talk of the aspect of data achieving, we are saying that implementing data achieving strategies for historical or infrequent access data, this can help maintain optimum database performance. Now, data achieving is very much important in your database. Your database should be able to keep information for a longer period of time. It must be able to keep data for a longer period of time. It can maybe, it should be able to keep even data from 2010. It should be able to keep data as low as 2000, 2010, 2022, 2023, just like that. It should be able to keep data into the archives. Very important. So data achievement, very important. And then there's also an aspect of scalability. Now, when you talk of the aspect of scalability, this entails that your database should be able to also accommodate growing data. So in case there's a lot of data that has been pumped into your database, it should be able to accommodate the increased data. And then there's an aspect of data migration, documentation, and performance tuning. And there's also an aspect of data caching. Now, when you talk of the aspect of data caching, also the database must have the information every time. The database must have the information every time. So this data caching, they are the small memories which keeps the database running. These are the small memories, just like the way the human being operates. Because even when the human being is sleeping and then somebody tries to wake you up, you still say something, even if it's not making sense. You still say something. So meaning the brain is able to keep certain information that even if, you are not, I've given an example, somebody sleeping and then you're being worked up and then you still say something as if it's not making sense. Even that's how also the database operates. There should be a memory that keeps the database running. Very important. So that is the aspect of data caching. And then there's also an aspect of testing. Testing is very much important in a database. Testing is also very much important in every project that you're working on. You need to test to see if it can actually perform accordingly. So now when you bring the aspect of testing here, rigorously test the database with representative data and query workload. So conduct stress testing, performance testing, and security testing. So it is very much important that you conduct performance testing to see how your database is performing. And then also you should be able to conduct the security testing. Is your database easily accessed? Can it be hacked? You should be able to conduct all those testing, which is very much important. And then apart from that, there is also the last one, part of database design technique, which is vision control. So here under vision control, we are emphasizing on that we are saying that apply vision control to the database scheme and code change to track and manage alteration over time. Utilize database migration tool for this purpose. Okay, so apart from that, in conclusion, we are saying that in this summary, effective database design technique involves understanding requirements, modeling the data, normalizing it, and considering factors like performance, security, and scalability. So here we're saying that it is very much important that you consider the aspect of understanding the you need to understand the techniques, the database design techniques before you embark on your database management. And then there is also an aspect of performance, security, and scalability. These are very much important in database design techniques. I hope you have enjoyed the video, guys, and don't forget to watch the next video. Remember, Just Life University, we are there to deliver. I wish you all the best, guys, and enjoy this festive season, guys, and make sure take care, guys. Please take care, enjoy, and take care. Okay, so definitely it's one of those points. Okay, so yeah, indeed.